Hi children, how are you? I hope all of you are enjoying with your families due to this COVID-19. Even though it is not good, but we got that time till now. And for the last 3 months, and we did not have any academic activities, and some of the children and forgot everything about regarding these academics. But now our management and Montessori group of schools are providing these video recording classes for us, and then this is not the substitute of our regular academics, but we will get the touch with our subject and we will have that more interest, and it is an easy and convenient to understand what we are going to discuss in the coming academic year. Okay, so this is Tirupati from Montessori group of schools and teacher of mathematics, and now we are going to discuss about this class 9 mathematics, that is the first chapter, real number. Already in our lower classes we have studied about these natural numbers and whole numbers, integers. Now I am not going to give any explanation regarding these numbers, because the many years, not even the last academic year, and that many years we have studied, and natural numbers are called as the counting numbers also, and 1, 2, 3, 4, and there is no end for these natural numbers, and the whole numbers are starts from that 0, 1, 2, 3, and here also we cannot find any the highest whole number. Like the integers, once you see here, that we can see that negative and positive, and also that 1 0. 0 is neither positive nor negative. So these three sets are available here, and just if you observe these sets once again very clearly, and 0, 1, 2, 3, and here it is a 1, 2, 3, 4, all these natural numbers are available in the set of whole numbers. That means we can understand now the natural numbers are the part of the whole numbers. At the same time, these whole numbers are also the part of the integers. But now in our 9th class standard, and just we are going to discuss about the rational numbers. That is the most important topic for us, rational numbers. Children, do you know anything about these rational numbers? And just you see here, a number which can be expressed in the form of P by Q. A number which can be expressed in the form of P by Q. What about these P and Q? P and Q are the two integers. At that same time, Q is not equal to 0. Why? If Q is equal to 0, is there any problem for us? Yes. Q is equal to 0. Q position is here, that the denominator. So whenever you write that 0 in the place of the denominator, and we cannot divide that P by the 0, it is not possible. So that we are considering now Q must not be equal to the 0. But P, even though it is a 0 also, the no problem, 0 by something is always that 0, so that there existing the value. So if a number which is expressed in the form of P by Q is called the rational number, and I will give a few examples of these rational numbers. 2 by 3, and 2 is an integer, 3 also the integer, and it is in the form of P by Q. So that 2 by 3 is a rational number, and 1 by 2 also the rational number, and 8 by 9 also the rational number. So in this way we can represent all the rational numbers, 2 by 3, 1 by 2, 8 by 9. But you have to see the definition of this rational number. Once again I am repeating the definition of this rational number. A number which can be expressed in the form of P by Q, where P comma Q are the integers, Q is not equal to 0. So this 8 by 9, one of the fraction, if you take it, and these 8 is P and this 9 is Q, and 9 is, we know that it is not the 0, so that it is satisfying that our given definition, so that it is called as the rational number. But once again you see here that the natural number 1, so 1 is also the natural number, 1 is also the rational number. Because just you think logically, and 1, how that 1, and just now we have discussed that all the rational numbers are in the form of P by Q, but here only the P, where is that Q? Nothing but 1. So if I write 1 by 1, what is the problem for us? 1 by 1 is equal to again 1 only, then this is also is equal to the 1. So without changing its value, just we have expressed in the form of P by Q. Here you see now P 1, q 1. So, q is not equal to the 0. So, that 1 by 1 it is also the rational number. Similarly, then you can take these 2 and you can write as a 2 by 1, 3 by 1, 4 by 1. So, from this is we can conclude that all the natural numbers are also in the form of p by q. So, the natural numbers are the part of the rational numbers. And just you see here the whole numbers 0, 1, 2, 3 so on. And if you write here for all these whole numbers also the divided by 1, and there also each and every whole number is also in the form of the p by q. So, that we can say all the whole numbers also the rational number. And similarly, if you come to these integers and minus 3, minus 2, minus 1, 0. Even if you write here also that by 1, by 1, by 1 and without changing its value, just we have explained, we have expressed each and every integer is in the form of p by q. So, that these integers also the rational number. That means, these natural numbers are the part of the whole numbers are the part of the integers and all these three together, and these are the rational number along with this, and we can write 1 by 2, 8 by 9 like this. And this is we can say x such that x is equal to p by q, where p comma q belongs to any one of the integers and q is not equal to 0. So, these are called as the rational number. Generally, these rational numbers are denoted by the q. It is denoted by the capital letter q. Why? Why we are expressing these rational numbers by using that letter q? Because just you see here the natural number, literally the natural number, the first letter of the natural numbers are taken here to explain that or to express that natural numbers. And whole numbers also we have taken that first letter w, but integers z. Here actually that integer should be explained by because of this criteria we should use that I, but we are not using that I because I we are using for the another set of the numbers. Later we can discuss this point, but now why did we use this z to explain these integers? Actually in the German word that Zellen is expressing that numbers, so that we are taking here z as the to express these integers. And here that q, why did we use this q letter to express that rational number? Just you observe once all these forms, p by q form, 1 by 2, 8 by 9. If you take anything also, these are just you see here, suppose I am asking that 1 by 2, 1 by 2, just you can divide 2 like this, and there is no chance to divide this and we can get here, what we can get, anybody can say that 0.5, because here the 0 and 2 5s are 10. So, 1 by 2 is equal 0.5, then what is this 0.5 here? It is the quotient. What is that? Quotient. So, every fraction this value is a quotient only. So, that these rational numbers are called as the quotient numbers. So, as that, and we are using the letter q to express that rational numbers. So, these are called as the rational numbers. But one thing, and just I am asking you one question here, can we write only these are the rational numbers? In any other forms are available to write that rational number? Just you think logically, and here I have explained already the 1 by 2, it can be expressed 0.5 also. Then 0.5, is it the fractional form? No, it is the decimal form. So, that rational numbers can be expressed in the decimals also. So, if you observe all these varieties of these fractions and what do you get here? Just let me explain here. Rational numbers, it is the fraction. This fraction can be expressed in the decimals also. These decimals again, how many types we can see that? One is terminating decimal, the another one is non-terminating decimal, Children, once you see here, I have explained about this rational number. The rational number can be expressed in the form of p by q, and p comma q are the integers, q is not equal to 0. Then we have explained, that means we have expressed that every fraction in the decimal form also. The decimal form is two types again. One of them is a terminating decimal and the another one is a non-terminating decimal. Again, these non-terminating decimals we can consider as the two types. We can classify into the two types. One is non-terminating recurring decimal, but I will tell you that here non-terminating non-recurring, but you don't think that all these are the rationals. No, because just you see here we are explaining about these decimal types and terminating decimal, non-terminating decimal. Terminating decimal means I have given that example 1 by 2. If you find this decimal presentation here, you are getting that 0.5. So that is called as the terminating decimal. And here non-terminating, again the two types are there. Non-terminating recurring decimal. Suppose if you take these 1 by 3 and divide it, and you will get a non-terminating decimal. But that is a repeating. It is a repeating. So 1 by 3, if you take it and divide this, 3 as a divisor, 1 is the dividend, and just you can, if you try to divide this is and point, and we can put that 0 here, and 3 3s are 9, and 10 minus 9 is equal to that 1. Again we can write one more 0 here, 3 3s are 9, again 1, and we can write the 0 3. So it goes on here, and there is no end in this division process, and every time it is repeating that 3 only here. So these type of decimals are called non-terminating recurring decimals. Understand? And then if you see that another one, non-terminating non-recurring decimals. Actually, if you divide any of these numbers, you will never get these non-terminating non-recurring decimals. And just I will give one example, 1.232456 and 1 8 so on. In this process there is no end for this number, and you will get continuously that digits here, and there is no particular pattern, or otherwise there is no repetition of that particular digit here continuously. So this is called non-terminating non-recurring decimal. So out of these three, out of all these forms, which are rational, which are non-rational numbers, we have to see that. And this is the rational part, and this is also the rational part. So, but this is called as the non-rational, that means it is an irrational number. What is that? Irrational number. So, terminating decimal, non-terminating recurring or the repeating decimals are called as the rational numbers. And but the remaining part, the numbers which are non-terminating, non-recurring decimals are called the irrational number. Children, just once you see here, we have discussed just the introduction of that real number. As a part of the real number, actually I have explained that only the one topic, that is rational number, and even we have to learn more about this non-terminating, non-recurring, that means irrational. In the next class we can discuss about that non-terminating, non-recurring decimals also. But you have to remember only the one thing, and rational numbers are the definition and the presentation here, and how can we understand. Suppose sometimes we may get that one doubt, then root 2 by root 2, somebody will ask you that root 2 whether it is rational or irrational. In such a case, some clever students can say that, sir, root 2 by 1 if I write, there is no change in its value, so that it is a rational number. This type of answers also we can expect, but you have to understand now, as per the definition, p comma q are the integers. Can you believe this root 2 is an integer? Actually, I am not going to that any discussion about this root 2, because that is a part of this non-terminating, non-recurring decimal. At that class we can discuss about that, but here the simply I can say this root 2 is not an integer, so that root 2 by 1 is not a rational number. Okay, children, take it seriously and don't think that it is just for the formality, and you have to understand this and if you understand and once you can take your textbook and go through it and find out some typical questions and try to solve them, or otherwise the easiest one already from our introduction we have discussed that. In the next class I can give that a more explanation about this real number. So till now we did not discuss anything about that real number, just I have explained only the rational number. Thank you.